Okay, in this video we're going to switch from indexing to concatenation. So again, we're using for loops to create vectors, and we're going to do this now using concatenation, which should make you think of square brackets. Okay, so let's say, again, we'll go back to our first example. We want a vector containing the squares of integers from 1 to 5. Okay, so the for loop might look something like this. So for n equals 1 to 5, inside the for loop, we are going to say a is equal to whatever a used to be plus the next value that's going to get added as we loop. Okay, so that would be n squared. Okay, and then we would want to take a look at a after the loop was done. So let's see what MATLAB does with this. Interesting. So MATLAB says undefined function or variable a. So let's look at this line of code right here. So I said a is equal to whatever a used to be, and then concatenating a new element n squared. But when it got here, MATLAB didn't know what a used to be because I didn't ever give it an a. Okay, so when we're doing concatenation, we always have to initialize the vector, and typically we're going to initialize it to be just an empty vector using empty square brackets. Okay, so a is basically an empty vector. I hit the loop, n is going to be a 1. My code right here is going to say a is equal to whatever a was, which was an empty vector, and then we're going to concatenate 1 squared. Okay, so if we watch this happening, a would be 1. Next time through the loop, n would be 2, and then a would become whatever a already is, which is a 1, and then concatenate 2 squared, or a 4. So now a would have 2 elements, a 1 and a 4, and so on, okay, until I built up all 5 elements of the vector. So let's go ahead and run that section and make sure a looks like what we think it should be, 1, 4, 9, 16, 25. Okay, perfect. Now, what if, like before, we want a vector containing the squares of integers from 0 to 4? Okay, we could copy this same code. So again, we need to start a out as an empty vector. Now, instead of n going from 1 to 5, we would simply have n go from 0 to 4. And if we run this section, we should get 0, 1, 4, 9, 16. Okay, perfect. So it's pretty generalizable. And as our last example here of simple concatenation to build up a vector, let's say that we already have a vector. So vector equals, in fact, let's just go grab that other crazy vector we had right here. Let's say that this is our vector, and we want vector containing squares of values in vector. Now, again, I know that we can use this with the dot asterisk matrix operations in MATLAB, but we're just trying to practice for loops, so humor me for a second. So here we would say for n is equal to 1 to length of vector. Let's do new vec again. So new vec equals whatever new vec currently is, and then concatenating to that vector element n squared, and then let's take a look at new vec. Now, we're maybe put a comment here. So we're concatenating, can't spell that very well, concatenating to build new vec, but we're indexing values out of vector. Okay, so we're building the vector using concatenation, so that's what we're what we're talking about in this video, right? But to make this work with our random vector, we do have to index out of vector. So it's kind of a combination of concatenation to build the vector and indexing out of an existing vector. All right, so hopefully that's not super confusing. Okay, so let's go ahead and run the section. Uh-oh, and I did it again. It got to this line where I said new vec is whatever new vec currently is, and it didn't know what that was. So I forgot to initialize new vec. So I will just make new vec an empty vector. And now this section of code should run without error. Okay, fantastic. So again, this is the most general way because we can have any vector. The indexing doesn't depend on whatever values are in the vector. The values don't have to be in any kind of sequence or particular order, right? We use the length function and just have n go from 1 to the length of the vector, and then we do need to index values out of that vector to build up the new vector by concatenation.